Hello and welcome to this demo. In this demo, we're going to look at updates and rollbacks in deployments. I'm on the Kubernetes master node and I'm going to create a deployment using the kubectl create command. First, I'm going to see if there's anything existing by running the kubectl get all command. And as you can see, there's nothing running except for the default Kubernetes service. So that is fine. I'm now going to create a new deployment by running the kubectl create deployment command. As soon as I run the create command, I could run a kubectl rollout status command to see the status of the rollout. As we discussed in the lecture, whenever a new Kubernetes deployment is created or an existing deployment is upgraded, it creates a new rollout. And a rollout is the process of deploying the containers in the backend. As you can see, it deploys one at a time. So you have, as you can see, 2 of 6, 3 of 6, 4 of 6, etc. And finally, when it deploys all the 6 of 6, the deployment is considered to be successful. We also discussed that whenever a new rollout is created, a new deployment revision is created. So if you run the kubectl rollout history command, so I'm going to modify my previous command and change status to history, you can see that it's created one revision, that's the revision number 1, but I do not actually see a change cause. That's the second column in the output. It says none. And that's because I did not ask Kubernetes to record the change that I made. In this case, it doesn't really matter because the first revision is usually created when we create the deployment initially. So what I'm going to do is I'm going to quickly delete the deployment by running the kubectl delete deployment command, just to do that again, but this time by asking Kubernetes to record the change. And as you can see, I'm just going to wait for all the objects to be deleted. When you run the kubectl delete command, it deletes all the deployment, the associated replica set, and the pods that were created as part of the deployment. So when I now run the kubectl get all command, you can see that it's all terminated and it's no longer seen. So that is good. Everything is clean and I can now recreate my deployment. So I'm going to run the same command, kubectl create, to create a new deployment. But this time I'm going to add a new flag called record, --record. And what this really does is we're just going to first see the status of the rollout by running the kubectl rollout status command. And as you can see, it's deploying one pod at a time. We will wait for all the 6 pods to be deployed. Okay, so the deployment is successful. Now I'm going to run the history command to see the revisions. And now, as you can see, there's a revision 1 as earlier, but you can actually see the change cause, which is the same command that I ran to create the deployment by using the deployment definition file. Okay, so now I'm going to make a small change to my deployment. If you look at the Docker file or the Docker Hub page for my ngInx image, you can see the versions. So here I'm using the image ngInx, which means that I haven't really specified a tag or a version of the image. So by default, it assumes it to be latest. And in this case, the latest version is 1.13.9. So we are actually at the latest version. We need to simulate an upgrade or a downgrade of the deployment or just a change in our application. So what we're going to do is we're going to use a new version or a different version of the image. In this case, I'm going to go with 1.12, which is actually the previous version of the image. Now I just need to simulate a change in the image. It could be an upgrade or a downgrade you're doing. We'll just assume that it's an upgrade. But since we're already at the latest version, we do not have a newer image. So we're just going to use another version, which is 1.12, and assume that we're upgrading the my application. So now I've made a change to my image, and I'm going to apply that change by running the kubectl apply command with the deployment definition file. And as you can see, it says deployment, my app deployment configured, which is good. And I'm now going to run the kubectl rollout status command to see the status of my rollout. As I said, an upgrade also initiates a rollout. Since we have updated the image of our application, it has to go out and update the image on all the replica set. Okay, so the deployment is successful. As you can see, I now have 6 nodes that are up to date, and I can see all the pods. And if I do a describe deployment command to see the details, I can actually see the detailed image name or the new image, which is NGINX 1.12. If you look at the events down below, you can actually see the events as it occurred. You can see that there are 2 replica sets mentioned here, of which one, which is the older one, is scaled down one at a time, and at the same time the new replica set with the newer image is scaled up one at a time. So you can actually see the events. Okay, and now I'm going to see the new revision that was created by running the kubectl rollout history command, and that tells me that there's a new revision, which is revision 2, and the command that I ran to create the new revision was kubectl apply, which is a command that I ran to upgrade the images of my NGINX containers. So that is good. Now I'm going to make the same change using another command, which is the set image command, and this is an alternate way of upgrading your NGINX containers or your application. And so you run the set image command and you specify the new version of your application by using a name and value format. So the name is the NGINX container, and the new version that I'm going to upgrade to is 1.12-Perl. So that's just another version of the NGINX container. Okay, as soon as I run the command, I'm now going to run the rollout status to see the status of my upgrade. Okay, so the rollout is now successful. I'm now going to see the history by running the kubectl rollout history command, and I can now see that there's a new revision, which is revision 3, and the revision was created by running the kubectl set image command. So I now have 3 versions of my application. The first one was simply NGINX. The second one was created when I ran the NGINX 1.12 image, and the third revision was created when I changed my application to NGINX 1.12-Perl. When I run the kubectl describe deployments command, I can now see the image of my application containers updated to NGINX 1.12-Perl. Okay, so let's pretend that there was an issue with the last change. Let's pretend that our application doesn't really work well when I use the 1.12-Perl image and users are reporting issues. So you're asked to roll back the last change that you made. So you can actually do that by running the kubectl rollout undo command and specifying the name of your deployment. And when you do that, of course, you can actually see the rollout status again, because that also kicks off a rollout. The rollout is now successful, and when I now run the history command to see the status of my revisions, you can now see that there's a new revision, which is revision 4, but you cannot actually see number 2. Now this is because when we did a rollback of our upgrade, it rolled back to revision number 2 because we were at revision number 3, and it actually created a new revision, which is revision number 4, and applied the same command that we used to create revision number 2 and also used the same definition file that we used at that time. So Kubernetes keeps a record of this internally, and so it takes us back to the version of container that we used in revision number 2. If I now run the kubectl describe command, I can now see that the image is now back to 1.12, which was actually revision 2. Okay, now let's take a look at another scenario where we have an error. So we will simulate an error by providing the name of an nginx image that doesn't really exist. So we'll make up a name, we'll call it 1.5-ERR. We know that this image does not exist, but our intention is to to simulate an error in deployment. So we've now updated our deployment definition file, and we're going to apply that changes using the kubectl apply command and specifying the deployment definition file as input. We'll also add the record parameter. Now, when I run the kubectl rollout status command to monitor the status of rollout, you'll see that it's actually stuck at that point where it says 3 out of 6 new replicas have been updated. So we know that at this point in the backend, it's actually trying to bring down the old replicas and bring up new replicas, but it's actually stuck at 3 out of 6. Now let's try and see what's happening. If you run the kubectl get deployment command, you can see that our deployment is in a different state as to normal. The desired number of replicas is 6. However, the current number of replicas is 8, and up to date is only 3. Now, if desired is 6, we would expect the current to be 6 and up to date to also be 6 and available to also be 6. But the recent change that we made is to update to an image that is not actually available. So if you run the kubectl get pods command to see the status of pods, you will notice that 5 of the old versions, which is the actual working versions, is available, and the new version, which is not actually available, there are only 3 pods created for that. So what's happened here is, as always, this is considered to be an upgrade, and the deployment object tried to terminate one instance from the old working version, so thereby bringing the total number of running pods to 5, and it tried to create 3 pods of the new version. However, the new version, as you know, is not right, and that's why you can see that the status is image pull back off. That basically means that the deployment is unable to pull the image from Docker Hub, and since it's unable to deploy any of the 3 images, any of the 3 pods, Kubernetes proactively stopped proceeding with the upgrade, and it proactively stopped terminating the old replica set, because it knew that if it did terminate all of the old replica set and tried to deploy all new replicas, then the users would be impacted because the new image does not exist. So it proactively stopped the upgrade, and it's now waiting for the new image to be available. If I now look at the rollout history command, I can now see that there's a new revision created, which is revision 5, and that was created by running the following command. I now know that there is an error with the image that I'm trying to download, so I'm going to undo that recent change by running the kubectl rollout undo command. And when I now look at the revision history, I can see that a new revision is created, which is revision 6, and it is going to revert to my 4th revision, which is actually now pulled out from the list of revisions. If you look at the image now, it is back to 1.12, and if I look at the pods, I can now see that I have 6 pods that are all in running state. Well, that's it for this demo. and I will see you in the next lecture.